Hello students, welcome to the first tutorial on units and conversions. In this tutorial, we wanted to see what techniques you can use to convert from one unit to the other. The methods that we use at this level are similar to the methods that you probably have been using at lower levels as well, but then all we wanted to see is how well can you present your work. Maybe that's going to be the main difference, the presentation. Otherwise, you can still work with the methods that you've been using all along and then just polish them up. Okay, before we look at where we're going in terms of conversions, I'd like to just point out a few things which are going to reoccur almost every time. Let's just look at what they mean and how they relate to the common or the standard units. So of course, most quantities will have units like if it's time, you're going to have seconds. If it's mass, you're going to have the grams. If it is distance, you're going to have the meter. So these are more like the standard units that we're dealing with, or the central points where units are going to be converted from or to in most cases. Now, when you want to measure a smaller unit of time, in most cases we add the prefix here, like a milli or a centi. Sorry, usually you don't use centi when it comes to time. You have a millisecond, a microsecond, and so on. Or maybe a centimeter, a millimeter, a micrometer, a nanometer, and so on. Now, what we want to see is what is the relationship between those suffixes, the prefixes, and the original units. Okay, so there are things that you already know. So you put them out there. So when we start using them, you already remember what they are. So of course, think about if you have, let's say, the nano. So nano, of course, if usually you use subscript n for nano. So if it's time, it's going to be nanosecond. And in most cases, you want to associate that with 10 to the power negative 9, because nano kind of talks about 9. So what this represents is that if you have, let's say, 1 nanosecond, then this will be equivalent to 10 to the power negative 9 nanoseconds. But the other way that you can present the same thing is by saying if you had, written nanosecond both sides, so this is a second. So 1 nanosecond is equivalent to that smaller value of a second, of the smaller version of a second, just that fraction of a second, in other words, or 1 over 10 to the power 9. Okay. If you wanted to look at it from a different point of view, it's by saying, okay, what if now you had 1 second? How many nanoseconds would make a second? Nanoseconds are smaller than a second. So now all we're saying is how many of those small nanoseconds would add up to make 1 second? In this case, we're saying since that is 10 to the power negative 9, the alternative will be 10 to the power positive 9 nanoseconds. Or you can have 1 with 9 zeros. Okay, so that's one thing. And then if you're dealing with micro, so micro is symbolized by that. It can be micro in terms of grams, or maybe micro in terms of meters, micrometers, and the effect or the influence is the same. So if this is the one that we have, of course, micro means 10 to the power negative 6. So when working with this one now, all we're saying is 1 microsecond, again, is equivalent to 10 to the power negative 6 seconds. So here we're saying the micro is smaller than the second. So to make 1 microsecond, it's just that fraction of a second. So if you wanted to see how many of these smaller microseconds add up to give 1 big second, 1 second, notice that now it's the same thing, that value, but now with the positive power. So if you had 10 to the power 6 microseconds, these will give you 1 second. Okay, of course, this relationship can continue with the milli. For milli, of course, now we're dealing with 10 to the power, and that's negative 3 seconds, and this can continue and so on and so forth. But one thing that I wanted to really focus on is, see, with these relations, you're seeing how you're converting from a smaller unit to the standard meter second. Now, what can be tricky at times for most students is, what if you wanted not to convert from the nano to the second? What if you wanted to convert from the nano to the micro, just here. You don't want to reach the second itself. You just want to convert from the nanosecond to the microsecond. Now, what I want to show you guys is a simple hack that you can just look at. So you know to say when you're dealing with nano, you're dealing with 10 to the power negative 9. When you're dealing with, this is for nano. So it can be nanometers, nanoseconds, it doesn't matter. But let me deal with seconds for now. And then when you're dealing with micro, you're dealing with 10 to the power negative 6. So what I want you guys to focus on is on the power. So the power of each unit, then nano has negative 9. So let's plug it there. So here then we have the micro. Micro has power negative 6. So to move from negative 6 to negative 9, you have first negative 7, then you have negative 8. Okay. So now what I want you to notice here is that these steps that you have to take, if you now wanted to move from 10 to the power negative 9 to 10 to the power negative 6, notice that first of all, you're moving to the right. So you're going to move one step, then the second step, then the third step. So I'm just looking at the powers. In other words, I'm looking at the difference in their powers. That is the one that is going to give me a factor that connects them. You can think about this, or you can say, okay, I'll just divide the powers. That's one way you can look at them. You can use the relationships that we gathered here to see a shortcut between them. But in most cases, I'll just look at the powers like this, look at the difference between the powers. Here, I'm seeing that the difference is a 3. So whatever, depending on whether I want to move from a small unit to a big unit, I know the power is 3. But if I'm looking at a small unit, 1 nanosecond, then I know since this is a smaller one, it will be equal to negative 3 microseconds. But if I want to say 1 microsecond, then this will be equal to the positive power, and that's positive 3 nanoseconds. So it's one thing that we're going to use when we got the questions. I wanted you guys to just have an idea of how it works. So with that in mind, you know the nano, you know the micro, you know the milli and its influence. Then of course we have the common ones like kilo as well. So just look out for those. Those are the most common ones, but they're not the only ones. We have things like deca, beca, and so on. There are a lot. There are a lot. The giga as well may be coming. So just look out for those. You can look them up, but the most common ones are the micro, the nano, the centi, the kilo. So you just want to know how to use them. Yeah, of course, the centi as well will keep on occurring every now and then. Let's look at a question. Let's look at a question. So now we're saying we have a hair strand. So we have hair that grows at the rate of 0.79375 millimeter per day. Find the rate at which it grows in nanometers per second. Now, because the distance between the atoms in the molecule is of the order of 0.1 nanometers, your answer suggests how rapidly atoms are assembled in this protein synthesis. That last part is just for your understanding. This is more like a question that has to do with human biology. So it's more like updating you or just letting you know to say what you have found, even though it's highly math here, doing the math here and there, but what you actually found, it actually defines how rapidly the atoms are assembled in the synthesis. Okay, now let's look at how we actually determine or how we work out this question. So how do we do that? Well, it's easy. What I want you to first do is first get what you're converting from, or the value that you're converting. So you're converting 0.79375. What I like doing is here I have units which can be written as a fraction. So I'm going to have this as a fraction. That's millimeter per day. So I'm going to write them like this. Now, to convert from millimeter per day, so I want to move from millimeter per day, then I want to go to, so where's that? Find the rate at which it grows in nanometers per second. So I want to convert from millimeters per day to nanometers per second. Okay, now how do I do that? Well, I'm going to use what I like calling converters. So the first, I identify how many units are involved, how many units I have to change. So I'm seeing that the millimeter changes to nanometer, and then the day changes to second. So I'm seeing a unit for distance changing from milli to nano. I'm saying a unit for time, changing for day to seconds. So in other words, when I'm converting this, I'm going to say I'm going to have two converters. One will convert that unit of length of distance. The other converter is going to convert that unit of time. Okay, how do we proceed? What are these converters? Well, the converters just show the relationship between the units you're moving to and from. Okay, let's look at the first one. So I have milli, I'm just copying that question again. Okay, so the converters are more like multipliers. I want to multiply the original function with 1 so that I don't change a thing. So what I'm going to put here is the thing I'm calling a multiplier, but then it's just 1, it has to be 1. Now look at this, it's a relationship between the millimeter. So here I'm converting from milli to nano. So the thing is, what is the relationship between them? So earlier on, we already looked at what we're doing when we're determining those. And nano is 10 to the power -9. Milli, in this case, milli is 10 to the power -3. So when I'm looking at the difference in their powers, I'm saying that the difference is 6. So now, depending on whether I'm moving from a smaller unit to a bigger unit, I can say the smaller unit, 1 nanoseconds. Now this, sorry, it's not time, it's distance. 1 nanometer will be equivalent to, that's going to be 10 to the power, that difference in their powers, that's 6. But since it's a smaller unit, I'll put a negative there. And then this is millimeter. But if I want the opposite, I don't like working with the negatives there, so I always prefer the alternative by saying 1 millimeter is actually equivalent, or we can make 1 millimeter if we had 10 to the power 6 nanometers. So mostly I'm going to use this expression, but even if you use the top part, it's the same thing. What this kind of tells you is that if I had 1 millimeter and I divide this by 10 to the power 6 nanometers, this is just 1 because they are equivalent. So when I divide them, I'm literally supposed to just get 1. Even if I had 10 to the power 6 on top, and then the 1 millimeter down, this is still the same thing. So whether I use this or I use this, it depends on what I'm working with. You'll see exactly what I mean with that. It's this presentation, it's kind of similar to when you have 1,000 meters making a 1 kilometer. Because the two are the same, if you wrote 1,000 meters over 1 kilometer, the idea here or the argument here is that this is basically just 1 because they're the same things. Okay, so with that understood, let's go back to our converters on top here. I'm going to erase this. Hope you get how they work. Okay, so here, of course, we saw to say that in every 1 millimeter, we have that was 10 to the power 6 nanometers. Okay, so once we've established this, you want to look at the unit you want to eliminate. You want to eliminate the millimeter, and it is in the numerator. Since it is in the numerator, we're going to put it in the denominator. So I'm seeing this is 1 millimeter. So in the denominator, I'm going to have 1 millimeter. And then the other unit is going to go up. So this is how I determine which one goes on top or which one goes down. So this part already eliminates or converts from millimeters to nanometers. Because when you look at it, this is going to cancel with this, and I remain with only the nanometer as the unit of length. Okay, the next one now is going to convert time. So again, I'm multiplying. So this time, I'm going to multiply with something that is going to convert my unit for time. Okay, now what is happening there? So of course, first and foremost, you want to know the relationship. Here we're moving from days to seconds. That's kind of a big jump. It's easy for you to know how many seconds are in a minute, but then you have to also know how many seconds are in an hour. Then eventually, how many seconds are in a day. Now, if you know to say that in every 1 hour, you have 3,600 seconds. So here, I'm assuming you already know this, but of course, it's something that is easy to look at. All you have to remember, maybe start from there, is that in every 1 minute, you have 60 seconds. But in an hour, you have 60 minutes. Meaning in an hour, you're now multiplying this by 60 seconds, because for every minute there, so you have 60 minutes, and then each one has 60 seconds. For every minute, you have 60 seconds. So when you multiply this, you see that in an hour, you have 3,600 seconds. Okay, so now you have 3,600 seconds in an hour, but in a day, you have 24 hours. Meaning, if you multiply this to get a day, then you have to multiply this to get by 24 to get the number of seconds in a day. Okay, so at this point, we're now seeing one thing. So in a day, so in one day, you have 24 hours. In every hour, you have 3,600 seconds. So what you get here is going to be the number of seconds which are present in one day. So when it comes to our converter here, so notice that what we're going to have here, we can do them one step at a time. First, convert from days to hours, then from hours to minutes, then from minutes to seconds. That's going to be a long thing. So here what I'm saying is, in every one day, so I'm saying my day is in the numerator, in the denominator here. So since my day is in the denominator, I'm going to put it in the numerator. The idea is that they should cancel out when I multiply. So in every day, I have 24 by 3,600 seconds. Okay, so once I've got this now, the rest is now just simplifying that expression. And how does it work? So of course, you multiply the top part. First of all, you notice that the day will cancel with the day there. So what you have is 0.79375 multiplying 10 to the power 6 nanometers over 24 by 3,600 seconds. So when you simplify that, you should see that you're going to get 9.19 nanometers per second. So this becomes the rate at which the hair grows in nanometers per second. Okay, so I hope you were able to catch how you're able to, that shortcut jumping from the millimeter to the nanometer. It's one thing that can be very helpful. But if you're not sure about that, or if you want to take the more standard approach, you can always first move from nanometers, go to the meter, and then from the meter, then that's when you go to the millimeter. Since you know the standard, you already know the relationship between the nano and the meter, and the meter and the millimeter. So you can take this longer route. But that shortcut I was showing you just moves from here straight away to that. Okay, so with that, let's look at another question just to help you guys understand how it works. Let's look at one more before we close this session. Let's look at this one. Okay, so with this question, what are they saying? So here we're saying you have a traffic light that turns green, and the driver of a high performance car slams the accelerator to the floor. The accelerometer registers 22 meters per second squared. Convert this reading to kilometers per mean squared. Okay, so again, it's the same thing. So the first thing I do, I want to write my value as a fraction. So what I have is 22, my units of the fraction, yeah, that's 22 meters per second squared. I want to convert it to kilometers per minute. So when I look at this again, so I have a meter per second squared. I want this to kilometers per minute squared. So I'm seeing I have two things that have to change. The meter has to go to kilometer. The second has to go to minutes. So how does it work? Well, again, my converters. The first converter will convert from meters to kilometers. The second one will convert from seconds to minutes. Now, how will it work? Well, the first one is easy. The relationship between the meter and the kilometer, I assume you already know that. So in every 1 kilometer, we have 1,000 meters. So of course, since I know 1 kilometer is the same as 1,000 meters, so all I want to see is I want to look at the unit I want to eliminate, the meter. It is in the numerator. I'm going to put it in the denominator. then the other unit will go up. Okay, next up, now I want to change that unit for second. You see, you might not know what second squared, how it relates to million squared, but always work with the basic. Don't start thinking about second squared just yet to say second squared is equals to the mean squared. You can't say 60 second squared is equivalent to 1 minute squared. I think this is a mistake that most students will make when they're handling this part. So what I'd like you to think about here is what you know. Well, you might already know to say in every 1 minute, you have 60 seconds. This is something that you might know. But how can you change from having a second to a second squared? You can't just multiply by s. Because if you multiply by s this side, you have to multiply by s the other side. But think about it like this. You can say multiply by a minute each side. So if you multiply by a minute this side, 1 minute this side, you're going to have now 1 minute, but now it will be squared. And then when you multiply the other side by a minute, you're going to have 60 by a minute. But I don't want to deal with this in terms of a minute. I want this to be on the right hand side. I just want to deal with seconds. So the minute on the right hand side, I can write it in seconds, which is just going to be 60 seconds. So this now becomes 60 by 60 seconds squared. Notice that now I'm saying 1 mean squared is equivalent to 3,600 seconds squared. So this is the relationship I'm going to use, but maybe this might be too long for you to do. We want to look at the easiest way to work out these questions every time. And remember, in the tests or exams, you're wrestling with time. One trick that you can do is when you're dealing with your converter here, stick to the basics. You're moving from seconds to minutes. So in every 1 minute, so I'm saying the second is down here in the denominator. I want it to be half. So I have 60 seconds. My minute will go down. I have the minute there. Once you reach this, for you to end up with the second squared, just square this thing. This is a shortcut that you can always take. If this was to the power 3, it was s to the power 3, especially when you're dealing with units for volume, and then have meter cubic. So just relate the meter first to wherever you're going. Then once you relate it, raise the whole thing to the power 3. That's a half that you can use. Okay. So once you're done with this part, the rest is simplification. So if we simplify this, you will see that what we now have is 22 meters per second squared. Let me get the whole thing first of all, so that you see how that square will simplify that. Then the other side, what we have is 3,600 on top, second squared now, over 1 mean squared. So from here, again, observe how the units cancel out. The meter will go out with the meter here. The second squared will go out with the second squared there. What remains is going to be 2 multiplying 1 kilometer here, multiplying 3,600 over in the denominator, it's just 1,000, multiplying the minute squared. If you simplify this, you're going to get 79.2 kilometers over the minute squared. But of course, this is just 79.2 kilometers per minute squared. Okay, so this is exactly how you approach this question. Let me know what you think. How did you find this approach? Let's interact in the chat section. Okay, otherwise, in the next session, we have one interesting question. It's not really very interesting. It's another easy one, really. Units and conversions are a little bit straightforward. I hope you guys are able to see that. So yeah, but if you have something that you feel is very interesting for a question, let's get in touch. We'll be happy to present it as well. All right, so in the next question, in the next tutorial, we're going to look at this question. And after that, we're going to see how we can use this, how we can use ideas from here to work out how we can move from a micrometer cubic to the millimeter cubic. We'll see that relationship in the next video. All right, guys, this is where we'll end this tutorial. Hope you were able to understand how to convert from one unit to the other. We'll see you in the next tutorial. This was your tutor.